Well, hi everyone. All right, we are doing piecewise functions, and they will make more sense. But let's first of all make a definition of piecewise functions. I'll write down that, and it is simply a function that is written using two or more expressions. Okay, not just a single expression, two or more expressions. All right, and then the domain, the piecewise function has a domain, and that is the values x can be, and the range, the values y, or maybe it's in function notation, y or f of x can be. Okay. There are certain steps. We're going to be graphing these, but the steps for graphing piecewise functions. Okay, you need a pencil, you need an eraser, because we're literally going to graph and then erase the parts that it's not in the proper boundaries, within the boundaries. That'll make sense, I think, once we start doing this, but we're going to use our pencils and our erasers to just kind of erase parts that don't belong, but we're going to graph whole things first and then figure out. But step one, you will see if x is less than -2, or if x is greater than -2 and less than or equal to 3, or something like that. You're going to see inequalities involved. What we will do with those inequalities is we are going to draw vertical, these are going to be vertical boundary lines and we're going to make them dotted because they're not actually part of the graph, but they help us determine. We're going to draw vertical boundary lines, and they'll be dotted on the graph. We will graph the first expression kind of completely. Graph the first expression. We will erase the parts outside the boundaries. Okay, and then just repeat. Repeat steps 2 and 3 for all of the other expressions. Okay, we do that, we're going to have it all graphed. I'm going to put a step 5 in here. We will, at the end of each one, we will determine the domain and range. Okay. Now you don't have to turn page. I'll do this. We're going to do 3 examples. And here's example 1. I think I can do it on this page just fine. Okay. f of x equals, then I make the fancy bracket there, equals -3 sometimes. And those times are when if x is less than or equal to -4. F of x will equal x sometimes if x is greater than -4 and less than 2. F of x might equal -x plus 6 if x is greater than or equal to 2. All right, so let's go at this. We're gonna draw our grid by hand on this. Okay, I'll just draw a nice big grid. I'm gonna go half marks on each line here. Okay, now make these vertical lines, these vertical hash marks on the x-axis. All right. Now, the boundary lines. Here's where we're going to get all the boundaries. This part. Now, x is less than or equal to -4. Well, x equals -4, 1, 2, 3, 4, right here. So I'm going to draw just the boundary here. I got -4. I'm going to draw one at 2 as well. All right, now I'm going to graph all three of these. I'm going to kind of graph light at the beginning and then decide where the boundaries are for this. But f of x equals -3. That's f of x equals -3 is like y equals -3. Okay, here's what I know. I know that this is a HOI, which means it's horizontal. It hits the y-axis at -3, -1, -2, -3. So I'm going to kind of go light. I'll go heavier in a minute here. But this is y equals -3 right here. That's this line right here. It's a horizontal line. It hits the y-axis at -3. Now, my boundary is when x is less than or equal to -4. Well, here's -4. This is my boundary. Less than or equal to. So I'm going to put a solid circle there. I'm going to just draw this one a little heavier, and I'm going to erase this part because we only use this line, that line I drew, we only use when x is less than or equal to -4. So that's the part there. Now, the second one is y equals x. Well, that's y equals 1x plus 0. So the slope's 1 and the y-intercept is 0. So I'm right here. Slope is 1, so I go up 1, right 1. Up 1, right 1. Up 1, right 1. Okay. I'll go down 1, left 1. Down 1 from here, left 1. Down 1, left 1. Down 1, left 1. Okay. Now, I'm going to get a straight edge out here. Now I'm going to do this lightly again. I'm going to graph it kind of like this. And then I want to determine what part of this line are we keeping. So when x is greater than -4, so here's -4, greater than, I'm going to put an open circle right there for that part of the line, and less than 2. Well, this is 2, and an open circle here. This is the main part of the graph, And these parts are outside of the boundary. This is the boundary for the second function. And then the third one, y equals negative x plus 6, is what I'm going to graph. Okay, the slope is negative 1, right? And the y-intercept is 6. 1, 2, 3, 4, 5, 6. Slope's negative 1. So down 1, right 1. 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 Down 1. Okay, pretty good shape here. I'm going to draw the line that we've made here. Lightly. Notice how lightly I'm drawing that. We are only using this line for x is greater than or equal to 2. Well, here's 2, so we're only using it over here. Greater than or equal to, I'm going to put a solid dot here, and then just follow this line like that, and erase this part. Let's erase the part that's outside of the boundary. And there is our graph for example 1. I didn't do step 5 on this one. Let's get domain. I like to look at the graph. Okay, we hit the negative 4. This kind of links us from negative 4 to 2. And this picks up at 2 and keeps going this way. The domain here is all real numbers. If you prefer interval notation, you go negative infinity to infinity. Now the range, y value. So how low will this go? It's going to go down forever. All right, and it hits all these values, keeps going up, but it has this high point where it stops. 1, 2, 3, 4. It looks like it stops at 4. And I'll put a square bracket on that. So I'm going to use interval notation when I talk about these. That is the highest point that y gets. That's as high as. All right. Now I won't forget to do the domain and range on the last one. I hope. Here's hoping. So I have 2x if x is less than or equal to negative 6. 5 if negative 6 less than x less than or equal to 2. And negative 2x plus 1 if x is greater than 4. Okay, let's draw our boundary lines. Let's draw our grid first, but then we'll draw our boundary lines. Okay. Negative 6 has a boundary line. 1, 2, 3, 4, 5, 6. So here's a boundary. Negative 6 to 2. Here's a boundary. We have another one at 4. 2, 3, 4, like right here. All right. Let's graph this first one. Y equals 2x The y-intercept is 0. The slope is 2. So we start here. I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. I'll do that again. Up 2 over 1. And then I'll go down to left 1, down to left 1, down to left 1. All right. Oh, it's a little crooked there. That was a little off. Up 2 over 1, up 2 over 1. Okay, looks a little bit better. Light. So I'm going to erase part of this. Okay, what part am I going to erase? All right, x is less than or equal to negative 6. Ooh, you're not going to see much of this. Here's negative 6. Less than or equal to negative 6 right here. Less than's over here, so I'm graphing this part right here, which is hard to see. And I'm erasing these parts. Okay, f of x equals 5. So that's like y equals 5. Y equals 5. 1, 2, 3, 4, 5. Here's 5 on the y-axis. Y equals 5 is horizontal, like we've discovered in the previous two examples. Now, that's when x is greater than negative 6. Put an open circle there. Less than or equal to 2, which is right here. I'll put a closed circle there. Oops. Oh, it's 5. Okay. Just looking at the wrong number. All right. So I got that. I'm going to erase this part of the line. I'm going to erase this part of the line. Then y equals negative 2x plus 1. Okay, this is the y-intercept, and this is the slope. 1, right here. That's where it hits the y-axis. I'm going to go down to right 1, down to right 1, down to right 1. Okay. Down to right 1. All right, so got enough to make my line there, I think. Lightly, again. Now where do I want to do this? When x is greater than negative 6, which is right here. All right. I can see I did the wrong thing for that part. Doggone it. That goes with x is less than negative 6. So actually this is the part. Got your eraser handy, right? That's the part I need to graph on that one. And then x is less than or equal to 2. So here, less than or equal to 2, I'm going to put a solid circle here. Erase that solid circle there. And it's between these two points here. We will be graphing that. I'm going to erase that. I'm going to erase this and this as well. Okay. Now, Oh my goodness. Alright guys, I'm sorry. That middle part was right. Okay. Jiminy Christmas. Alright. Okay, let me get this part back where it was. I lost concentration completely there for about 2 minutes. Okay, maybe more. Alright. So we're okay here. We've got this part for this. We've got this part for this. Now I'm here. Negative 2x plus 1. 1 is right here. That's the part. Okay, so I kind of know where it's going. And down to right 1. There. Down to right 1. I'm here. Down to right 1 here. Down to right 1 here. Let's go down to right 1 here. Okay. Alright. I'm going to lightly do this again. But x is greater than 4. So right here, 1, 2, 3, 4 is that boundary line here. And I'm going to put an open circle right here and go this way with it. And then I'm going to erase this and erase this again because I'm a goofball. Alright, so just these 3 parts are the graphs. Now that I'm back into the problem, concentrating, let's put the domain. We pick up, this is x less than or equal to negative 6. This takes up negative 6 and gets us to 2. So I'm going to go negative infinity to 2, inclusive, with the square bracket. But then we have this gap between 2 and 4. You see that? There is no part of the line of the graphs that are ever going to touch that. So I'll put a U, and I will pick up with that 4 to infinity. There's my domain. Now my range, it goes down to negative infinity, comes up to, what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it looks like about negative 11 there. Negative 12, actually, I think. Negative 12. But then it picks back up here. From negative 12, it'll come back up to this point. 1, 2, 3, 4, 5, 6. This is negative 7. That's an open circle, so I'm going to put a curved bracket. And then, well, this is weird. We get up to 1, 2, 3, 4, 5. We get up to 5, but we do not go higher than 5. I'll put square brackets because it'll do 5 for the range. That is strange. I don't think I've done that before. Too much, anyway, that I recall. All right, guys.